Good day guys, welcome to my channel. Please don't forget to subscribe, like and comment. Today we're going to look at question 8. This is from paper 1 of 2018 November. So 8.1 says we must determine f prime x from first principles if it is given f of x is equals to s squared minus 5. So we are still continue with finding the derivative. So as we know, f of x is x squared minus 5, then we must find f of x plus h. This is from the formula. Whenever there is x, we're going to replace it by x plus h, which is going to give us x plus h to the power 2 minus 5. As we expand it, we're going to get x squared plus 2xh plus h squared, quadratic equations, minus 5. So to complete the whole formula, you'll find that f of x, f prime x is going to be equals to h when it approaches 0, then f of x plus h minus f of x. So we know what is f of x plus h. We'll replace it there, which is x squared plus 2xh plus h squared minus 5. Then minus f of x, which is going to be x squared minus 5 over h. I forgot to put denominator here is an h. So what's going to happen is that this x squared is going to cancel this x squared, because negative x squared plus x squared is 0. And then this 5 is going to be positive. Negative multiplied by negative is positive. So minus 5 plus 5, they're going to cancel each other. So in that case, we're going to be left with 2xh plus h squared, which we can therefore extract h because it's common in these two terms. It's going to give us h multiplied by 2x plus h over h. Now this h is going to cancel this one. Then we are going to be left with an h approaches 0, 2x plus h. Then our f prime x therefore is going to be this 0. We're going to replace it there to h, and then we are going to be left with 2x. Question 8.2 says we must find the derivative dy by dx of 3x cubed plus 6x squared plus x minus 4. And the derivative in this case is going to be 3 times 3x to the power 3 minus 1. This part, when we differentiate, and plus 6 multiplied by 2 x to the power 2 minus 1. This part there, and then x is going to be 1 x 1 minus to the power 1 minus 1, which is going to be 0 there. Then the derivative of minus 4 is 0. So we're going to simplify it further. Put 3, and we say 3 x to the power 3 minus 1 is going to give us x squared plus 6 2x to the power 2 minus 1 is going to give us 2x. 2 minus 1 is 1 plus 1 x to the power 1 minus 1. So x to the power 0 is going to give us 1. Then as we simplify it further, we're going to say 3 times 3 is 9x squared plus 12x plus 1. So it's as simple as that. Question 8.2.1. In my days, I will regard this as the standard grade type of question. Then question 8.2.2, we have to find dy by dx of this expression here. What is important is that firstly try to simplify the equation as far as possible so that you can therefore find the derivative. And what is important here is that x should not be 1, because I want to believe you will have a denominator whereby if x is equals to 1 is going to give us 0, and anything that you divide by 0 is undefined. Therefore, let's simplify this expression before we can find the derivative. What is common here? It's y, so I'm going to take out y. When you multiply it by s, it's going to give you yx minus 1. When you multiply y by minus 1, it's going to give you that minus y. It's equals to, there's something common there. Then 2 is common. In fact, 2x is common. And multiply by x is going to give you 2x squared minus 1 is going to give us x minus 1. Therefore, for us to get y, we have to divide by x minus 1. Even on the right side, we have to divide by x minus 1, where is going to give us y, because this one is going to cancel this one is going to cancel this one. Gonna get 2x, and dy by dx of 2x is 2. 1 is going to come here, then 1 minus 1 is 0, then anything to the power 0 is equals to 1. So that is our derivative of this expression. So thank you guys for watching my channel. Please don't forget to subscribe, and most importantly to comment. I think that one will assist one to be able to improve. But I believe this was one of those revisions that one can take home and practice until perfect. When the exam comes, I believe one will have learned a lot from my channel. But thank you once again. Hope to see you in the next video. Bye.